Hello, my name is Tejas Kulkarni, and I'm in 5th grade. I'm doing this physics course with my dad, hoping to learn a few new things about physics. So, in this lab, we chose our experiment. So, we found a video of Commander David Scott dropping a hammer and a feather on the moon to demonstrate that they touched the ground on the moon at the same time. This demonstration was done by David Scott using a geology hammer and a falcon feather at the end of the Apollo mission that landed human beings on the moon for the first time in 1969. We thought it was an excellent opportunity to measure the actual speed of the objects David Scott dropped and the time by these objects to hit the ground on the moon. We then compared it in Python by building a model using the gravitational acceleration of the moon. So, the gravitational acceleration is calculated by this formula: g multiplied by the mass of the moon divided by the radius of the moon squared. G is the gravitational constant, which is equal to 6.67 multiplied by 10 raised to minus 11. The mass of the moon is 7.34 multiplied by 10 raised to 22 kilograms, and the radius of the moon is 1,737.4 kilometers. So with the formula, we calculated that the gravitational acceleration on moon is 1.6 meters per second squared. We use this value of g to calculate the position in our model for the feather as well as the hammer. We will then read the positions exported from Tracker from a CSV file and animate both and model and observe positions to see how closely they match with each other. We found from NASA's website that the length of the hammer was 39 centimeters, so we used that for our calibration stick in the Tracker. We saw the model closely matched with the observed positions from the video. We're not going to show you the video and Tracker and the graph we acquired from it. This on the right side is the feather, and on the left side is the hammer. As you can see, they both hit the ground at the same time. Now I'm going to show you the graph for the hammer. It's pretty straight, and the x-axis doesn't have many interferences. And now the graph for the feather. So the x-axis is still pretty straight, and the y-axis has a little jump. That is mostly because the video is blurred, so we couldn't see it very clearly. In VIDLE, we are going to build a model. We are also going to read Tracker data and see how closely they match. So hammer and model observed positions are red, and the hammer and feather observed positions are blue. This data comes from Tracker. We made two arrows. One arrow is yellow, the other is blue, and they both show acceleration. These are the initial conditions, and they come from Tracker. This is the hammer's model position, and the hammer's velocity is 0. This is the feather's model position, and the feather's model velocity is also 0. We calculated delta t to 0.067, and we used that same one that we saw from the video. We got some files from Tracker that we used, and we got data from the files. This is how we calculate the hammer and feather velocity, and this is how we calculate the hammer and feather positions. The arrow scale we set is 0.25, and we wrote some files that helped us compare. Now we're going to run the module. As you see, the modeled and observed positions are very close, so that means our prediction was very close. Now we are going to show you a conclusion in word. We can now draw a conclusion to our adventure. We see that the feather wobbles a little in the X direction. We all know that there is no wind on the moon. The wobbling is mainly because the video is unclear and I was not perfect in locating the feather each time I clicked on it in Tracker. There is a 2 to 3 difference between the percent difference between the modeled and observed positions of both the objects. I think this is largely from the poor quality of the video and perhaps the camera is positioned at an angle causing some distortion. The gravity on the moon has a variation of about 1.6% depending on where on the moon you are, so that could account for some of the difference. Also, my clicking for the positions in Tracker was not perfect, so some error definitely crept in because of that. However, by and far, the observations from the video match pretty closely in the modeled positions and velocities for the hammer as well as the feather. Given the number of different factors that impacted the accuracy, the matching within 2 to 3% is remarkable. I hope this evidence convinces the skeptics of the moon landing that it actually did happen. The data in the video and our model definitely says so. If you want to watch the full video, we're going to attach it to the end. Thank you.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the 2 of them here and hopefully they'll hit the ground at the same time. How about that? Proves that Mr. Galileo was correct in his findings.